Hello.
Hello!
Hello, Mr. Ryan. How are you today? Good. Okay, so we may talk about a compression. What's this word? Compress, and decompress.
It's impressed.
No, decompress.
You
What's these
press
two words in English?
You press something.
No, compress, and decompress. Compress. Let's
You
say
press something at .com.
I have some data, and I want to send it over to internet. Send over the internet. You know the internet to your friends.
Yeah, that's what I said.
What?
It's pushing into the internet.
Pushing into internet? Oh, no, not yet.
Pressing into the internet.
You have a data, like you have a very big data, very big data, like a picture. Yeah, a picture of you, right? And it's a very
Really?
big, yeah. Yeah, it's very big, maybe 1 megabyte. This is the data size. Byte. In computer, 1 byte, yeah? 1 byte equals 8 bit, yeah?
Oh,
And then 1
how
kilobyte.
big is it?
1 kilobyte equals this is 2 to the power of 10 bytes. And then 1 megabyte equals 24 KB. And then what's that? 1 gigabyte equals 1024 MB. Okay, and then 1 terabyte. Yeah, this is the unit. Yeah, it means how big is the data. Why is it 1024? Because it's 2 to the power of 10. 2 to the power of 10, right? Okay. 1 byte, 8 bit. What's bit? Bit 0,
byte.
1.
You bite.
No. The
You're
byte.
biting.
No. Listen to me. Bit. The basic information to storing the data. 0 or 1. Right? Because computers uses the electricity, right? Then the electricity has this on off, right? And the voltage will be high, low. So it's binary. Yeah, that's why we always talk about binary in computer science, right? Because 0, 1. You make a computer chip circuit. You can control the electricity, right? Can control the flow. 0, 1. 1 byte, 8 bit. Okay. 1 kilobyte. So 1024 byte, okay, and then so on. So look, if it's 1 megabyte, if I have two pictures, one size is 1 megabyte, and the other one size is 10 megabyte. Which one do you think is faster to send over the internet? If you want to send it to your friend, Ryan, if you want to send it to your friend, Lucas, yeah, and that's Ryan, yeah, you want to send it over the internet, right? Which one you think it'll be faster to send?
10 MB.
1 megabyte and 10 megabyte, the data.
1 megabit.
Why is that?
Because it's smaller.
Way down, it's smaller, right?
Yeah!
It's smaller.
Yeah!
Okay, so this is uncompressed. Okay, can I have your attention, please?
Ryan, keep on hitting me.
Okay, sit there, please. Okay, so now, how about if I say I have 10 megabyte? If I compress it to, let's say I compress it to 1 megabyte, and before sending, I compress it, and then when Lucas receive it, he receive 1 megabyte of data. But
Yeah, but he doesn't see it straight in it.
he doesn't see the 10 megabyte data. Then on this side, he needs to decompress the original data to become a 10 megabyte. Then he can view the picture, right? Let's compress and decompress. Make sense? So why are we doing this? Because we want to shorten the time to send over the large amount of data. Because the traveling to send over the internet, it takes time. And generally, the less amount of data, the faster, right? Am I right? It's quicker to send over like 1 picture rather than 10 picture, right? Am I right? Over the internet, because the computer needs to, to travel to route, do the routing cables, going through the city, maybe going to another continent, in China, right? It takes time. Let's compress, decompress. Okay, compress. So compression has 2 kinds of compression. One is lossy. The other one is loosely. So can you?
Lossy.
So how does it mean? Lossy.
It means you keep on losing stuff.
Well done, and lossless is the opposite, right?
Yeah.
So why is that? Sometimes look. Okay, so the lossy. if for example you're making calls, yeah, you're making calls, it's a bit, maybe a bit okay to, you know, to lose some data. The people over the other end can still hear you, right? A picture, you compress the picture, right? You know that nowadays the camera, right, very high quality. You take a picture and 10 megabytes, but it has some details that human eyes cannot tell, right? A big picture, if I compress a little bit, your eyes cannot tell. So it's okay, it's lossless. It's lossy, right? And lossless is the opposite, like data, very important, you can't lose anything, right? I compress the data, and when I do the decompression, it needs to be fully, it needs to be exactly like the original, right? Okay? Okay, this is compress and decompress. Okay, so one way of doing it, can you tell me how can, look, let me show you a few data, and I want to send it over the internet, and can you tell me how do we compress it? You know, just any idea. Look, I have this data, yeah? A, B, 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 C, 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 C. Okay, that's it. So we want to send this data. We want to send, no, that's it. We want to send this data over internet to your friends. What's your approach? Look, there are 4 A's, 5 B's, and 4 C's.
You get them.
Look, there's 4 plus 5 plus 6.
9.
4. That's 13 bytes, yeah? 13 bytes. 1 byte, 1 character, yeah? Okay?
13 bytes.
Yeah, 13 bytes. That's the amount of data.
It sounds like you.
That's the amount of storage that required by a computer to store this data. A character, yeah? Remember, we talk about ASCII.
Why?
ASCII, remember? American Standard. I have no idea what's the code mean. Information exchange or whatever, yeah?
I think it's coding.
Coding, inter-exchange information or whatever. Yeah. Look, A, 97, yeah? Remember? A, 65, right? Do you still remember this? Yeah? So, look, the ASCII is from 0 to 255. What's that? That's 1 byte. Why is that? 1 byte, 8 bit. 8 bit. 2 to the power of 8. Right? That's 256. 256 is from 0 to 255. Okay. So let's 4 bytes, 5 bytes, 4 bytes. That's 13 bytes. Okay. I have to, if I'm not compressing this. If I'm not compressing this, how many I need to send 13 bytes over the internet? Is there a way that, you know, you and your friend, like your friend Daniel, Lucas, yeah, can decompress on the other side? Look at this pattern. Let's be fair. I give you one hint. If I have this a million C here, a million C, are you actually going to send a million C over there?
No.
Then how do we tell Lucas, your friend, Daniel, your friend, to decompress it? You know, instead of receiving that a million C at the end, can we just tell that it has
1 byte?
Has how many number of C at the end, and then Lucas can reconstruct the data, right? So how about if I tell, if I compress this using look 4 times A, 5 times B, yeah, a million, I don't know a million. How many zeros?
6.
6 zeros. C. Okay, how about if I sending this over the internet? And when Lucas or Daniel receive on the other end, he receive exactly the string, but this is the compressed version, so he can compress it, decompress it. He can decompress it. Yeah, he said, okay, I see. It's 4. I have received a sequence 4 A's, 5 B, and a million C. So you will try to put a B, 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 and then a million C. Okay. So which one is quicker? Which one is quicker? Which one is quicker? Very obvious. Which one? The second one, yeah?
Yeah.
Yeah, because look how many characters we need to see. How many bytes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah? 12 bytes. And how many bytes here? A million and
9.
a million 9. Wow, that's a huge save, right? Make sense? Yeah? That's compression. That's what this is one of the basic. This is one of the basic techniques, okay? There are many compression algorithms, right? And this is one of the very basic. It's called run length. Run length. Why is it called run length? Because look, you're running, and this is number of lengths, yeah? Run length. Yeah? What did he say?
Run length.
Yeah, this is kind of run length algorithm, okay? And then let's do this. If we have a data, you know, which is the encoded version of the run length, yeah? For example, like, what did we just say? 4A, 2B, 3C. And then there's only the lowercase characters, okay? If it doesn't contain the numbers, yeah, because if it contains number, there's no way to tell if it's one part of the, yeah, there's no way to tell if it's part of the length or it's part of the data. Okay, so given this data, we want to what's the decode version of the original data? 4A, 2B, 3C.
A, B, C.
We're done. Okay, so that's it. Today's task. Yeah. So we can just go through that. This algorithm is quite simple.
3C is a class.
Yeah. So we just go through this, pass this string character by character. If it's a digit, we remember it, and if it's a character, we remember it. And at the end, we can use these. Remember, we can use in the Python. Yeah, in the Python. Look, what's this? 4 times A in Python, right? That will give A, right? Are we right?
Yes. I'm
Okay.
not holding anything.
Okay, how about 0 times ABC? What's this? 0 times ABC in Python.
0 is
No,
nothing.
It's nothing, empty string because it's 0.
Hey.
And how about 2 times AB? What does it equal?
A,
We're done.
Hey.
Okay? So we can use, look. Can you go there, sit please, Eric?
I am.
Sit there.
Yes.
So we can have a data array, right? So first, this is the array. So look at me. How I go through this algorithm. Look. Okay, if it's a number, I remember it is 4, right? Okay, the next one is
The letter.
letter A. Then I push the number and A in this. And then number 2 again, I remember this. And B, right? And I push it again, 2 and B. So and then again 3C, right? 3C.
3C is a class.
Okay. So eventually we have this data array which is like that. Okay, how about the digits could be multiple, right? It could be more than 10. So if I have 33C, if I have 33C, right? So we have first of all we remember the number 3, but the second time is also a digit. So we need to update the number with to 33, and then until we meet a character, a data, yeah. So we put it here. We just put every time we push a pair, which is the number of times the data has occurred, right? Once we have this data, we can just return.
So it'll become C.
Return what? Return. Remember what we join, yeah? Join what?
C.
Stop it.
C.
We want to join these two, right? We want to join these two. So data I times data A plus 1, right? Data I times I plus 1 for I in range length data. Right? And the step is 2, right? Because every time we go 2 steps, it's 4 and then 2 and then 32. So every time we construct this piece, and then we join it together. Okay, but let's implement this, okay? Let's implement this. What did you just say?
Gonna implement it.
Yeah.
Define.
I'm a football player.
Run length. Okay, then we have this the string S. First of all, we need to account C equals 0, and we put this answer in the list, right? And then we go through this number. We go through this string, yeah? Remember this 2a, 3b, 3a, 33b, 2c, okay? That's that. We go through this number. And then if how do we check if this I is an integer, is a number?
It's a letter.
It's a letter, it's a digit from 0 to 9, yeah? It's a number, so we can do this. If I dot is digit, yeah? Python has this function to check if it's digit. So this is the same thing as if I is bigger than 0, smaller than 9, right? Or you can do this ORD thing. Remember ORD 0 is what? 48, right? Is it 48? Yes. Okay. If I is digit, if it's digit, then I want to update the number, which I can say c equals c times 10, right? Look, I'm currently at 3, and I want to make 3 to 33. How can I do this? 3 times 10 plus the second 3, yeah? 128, if c is 100, if 12, and how can I make c to be 128? C times 10 plus a, right? Got it? That's how we get the number. C equals c times 10 plus the I is a digit. So one way of doing it, we convert the digit to the integer. Or we can do this. We can do this ORD I and minus 48. Yeah, this is the same thing. Yeah, because the ASCII code of 0 is 48, and we just need to minus that. If it's a number, we just update the c. And if it's not a number, we need to append it to the data, yeah, to the answer. Answer dot append c, right? And what's the next I need to append? Remember I have these 2 and then a. I need to append these, yeah? 33 and b, right? So what's this? Answer dot append what? I just pointed. I. Right?
That's the wrong letter.
Yeah? So once this I, we push it, then we need to update the counter to what? We have to update the C to what? We have used it, so we have to prepare for the next iteration, which is to be set to what? The counter. How many? C is the number of characters, for the following characters. So what should I update C to? Any idea? C equals what? Come on. C equals what? Remember, we have used this 22b, and then before we want to process to next pair. So what's C equals to at the beginning?
2.
No, the 2 is the next one. What is 0?
Nothing.
Nothing. What's nothing in numbers?
List.
What's the nothing? What's
0!
0. Come on. Okay.
I'm a football player.
Okay. Now look. Okay. Can you tell me what's the answer after this? Right? If the S is 2A, 32B, 7C. So can you tell me what the answer is? What does the answer contain?
A.
No. The answer is the list. Remember, we append C and I to it. We append C and I to it. So what's the answer going to be like? It's a list of pairs. C and I. C is the number. Come on. It's a pair of it append the C and it appends the I. So what's C for the first pair?
2.
Come on, what's that? Next.
A.
And then? Come on.
A, sorry.
33. And then?
B. 7C.
Yeah. Okay. So that's what this piece of work does, to convert this S into this bit. Yeah. But this is not a final answer. We need to use the times this together. Yeah. 2 times A. 33 times B. 32 B's together. 7C, C. Then we need to join them together. So we just return. Yeah, I've written this before, right? Join answer I times answer I plus 1. Yeah. Answer I times I plus 1 for I in range. How many of these? Length data. Okay, it's actually it should be 0 length data 2, right? Because start from 0 and up to length data, and the step is 2. The step is 2. Okay? Okay, so make sense?
Yeah.
So what's this bit? Can you tell me what's this bit?
It's doing this.
So what does this mean?
So this times this.
This times this and this times
and
this,
times this.
and then put it all together, right?
Yeah.
This times this, yeah. Answer I is here. Answer I
Join
times
with
here.
a space.
Join no space for I in range that, yeah. Okay. What's the time complexity?
O-N.
What's n is the number of string in character, yeah. What's the space complexity? Are we using the space?
O-N.
Yeah. Okay. Okay, that's it for today. Bye bye.
Bye.
Bye bye.